let's do a couple of problems graphing linear equations. And there are a bunch of ways to graph linear equations. And what we'll do in this video is kind of the most basic way, where we'll just plot a bunch of values and then connect the dots. And I think you'll see what I'm saying. So here I have an equation, a linear equation. I'll rewrite it just in case that was too small. Y is equal to 2x plus 7. And I want to graph this linear equation. Before I even take out the graph paper, what I could do is set up a table where I pick a bunch of x values, and then I can figure out what y value would correspond to each of those x values. So for example, if x is equal to, let me start really low. If x is equal to minus 2, or negative 2, I should say, what is y? Well, you substitute negative 2 up here. It would be 2 times negative 2 plus 7. So this is negative 4 plus 7. This is equal to 3. If x is equal to, I'm just picking x values at random that might be indicative of, I'll probably do 3 or 4 points here. So what happens when x is equal to 0? Then y is going to be equal to 2 times 0 plus 7 is going to be equal to 7. What about, I just happen to be going up by 2. You could be going up by 1, or you could be picking numbers at random. When x is equal to 2, what is y? Well, it'll be 2 times 2 plus 7. So 4 plus 7 is equal to 11. And I could keep plotting points if I like, but we should already have enough to graph it. And actually, to plot any line, you actually only need 2 points. So we already have one more than necessary. Actually, let me just do one more just to show you this really is a line. So what happens when x is equal to 4? And actually, just to not go up by 2, let's do x is equal to 8, just to pick a random number. Then y is going to be 2 times 8 plus 7, which is, let's see, well, this might go off of our graph paper, but 2 times 8 is 16, plus 7 is equal to 23. Now, let's graph it. So let me do my y-axis right there. That is my y-axis. And let me do my x-axis. Let's see, I have a lot of positive values here, so I want a lot of space on the positive y side. So that is my x-axis. And then I use the points x is equal to negative 2. Negative 2, that's negative 1. That's 0, 1, 2, 3, 4, 5, 6, 7, 8. Those are our x values. And then we can go up into the y-axis. I'll do it at a slightly different scale because these numbers get large very quickly. So maybe I'll do it in increments of 2. So this could be 2, 4, 6, 8, 10, 12, 14, 16. And I could just keep going up there, but let's plot these points. So this first coordinate I have is x is equal to negative 2, y is equal to 3. So it's the point, so I could write my coordinates. It's going to be the point negative 2, 3. X is negative 2. Y is 3. 3 would land right over there. So that's our first one, negative 2, comma 3. Then our next point, 0, 7. Let me do it in that color. 0, 7. X is 0, y is 7. Right there. 0, 7. Then we have this one in green here. Point 2, comma 11. 2, comma 11 would be right about there. 2, comma 11. And I have this last point. This is actually going to fall off of my graph. 8, comma 23. 8, comma 23, that's going to be way up here someplace. If you can even see what I'm doing. This is 8, 23. And then if we connect the dots, you'll see a line form. So let me connect these dots. It should be. I've obviously hand drawn it, so it might not be a perfectly straight line. But if you had a computer do it, it would be a straight line. So you could keep picking x values and figuring out the corresponding y values. In this situation, y is a function of our x values. And if you kept plotting every point, you'll get every line. If you picked every possible x and plotted every one, you'd get every point on the line. Let's do another problem. At the airport, you can change your money from dollars into euros. From dollars into euros. The service costs $5. And for every additional dollar, you get 0.7 euros. Make a table for this and plot the function on a graph. use your graph to determine how many euros you would get if you give the office $50. All right, so I'll write euros is equal to, so let's see, it's going to be dollars. So you're going to have to give your dollars. Right off of the bat, they're going to take $5. So dollars minus 5. So immediately, the service costs $5. And then everything that's left over, this is your leftover, you get 0.7 euros for every leftover dollar. So you get 0.7 for whatever's left over. So this is the relationship. Now, we can plot points. We can actually answer their question right off the bat. If you give them $50, we don't even have to even look at a graph, but we will look at a graph right after this. So if you did euros is equal to, if you have given $50, it would be 0.7 times 50 minus 5. You gave them 50. They took 5 as a service fee, so this is just $45, and it would be 0.7 times 45. And I could do that right here. 45 times 0.7. 7 times 5 is 35. 4 times 7 is 28, plus 3 is 31. And then we have only one number behind the decimal, only this 7, so it's 31.5. So if you give them $50, you're going to get 31.5 euros. Euros, not dollars. So we answered their question, but let's actually do it graphically. So let's do a table. Let's say, and maybe I'll get a calculator out. I'll refer to that in a little bit. So let's say dollars, you give them. Dollars. And how many euros do you get? And I'll just put a bunch of random numbers. You got to give them, if you give them $5, they're just going to take your $5 for the fee. You're going to get $5 minus 5, which is 0, times 0.7. So you're going to get nothing back. So there's really no good reason for you to do that. Then if you give them, I don't know, $10, what's going to happen? If you give them $10, 10 minus 5 is 5 times 0.7 is you're going to get $3, or I should say 3.50 euros. 3.5 euros you'll get. Now what happens if you give them, I don't know, let's say you gave them $30. Actually, let me say 25. If you give them $25, 25 minus 5 is 20. 20 times 0.7 is $14. And I'll do one more value. Let's say you gave them $55. And this makes the math easy, because then you subtract that 5 out. 55 minus 5 is 50, times 0.7 is 35. $35. Wait, is that right? Yep, that's right. You'll get 35 euros, I should say. These are all euros. I keep wanting to say dollars. So let's plot this. And all of these values are positive, so I only have to draw the first quadrant here. So all of these values are positive. And so the dollars, let's go in increments of 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55. I made my x-axis a little shorter than I needed to, all the way up to 55. And then the y-axis, I'll go increments of 5. So that's 5, 5, 10, 15, 20, 25, 30, 35. Well, that's a little bit too much of an increment. 35. All right, now let's plot these points. I give them $5, I get 0 euros. So this right here is euros, and this is the dollars. The dollars is the independent variable, and we figure out the euros from it. Or the euros I get is dependent on the dollars I get. If I give $10, I get 350 euros. So 350, it's hard to read. Maybe 350 will be right around there. If I give $25, I get 14 euros. 25, 14 is right about there. Obviously, I'm hand drawing it, so it's not going to be quite exact. And if I give $55, I get 35 euros. So 55, 35 right there. And then if I were to connect the dots, I should get something that looks pretty close to a line. And if I did it, if I was a computer, it would be exactly a line. That looks pretty good. And then we could eyeball what they asked us to do. Use your graph to determine how many euros you would get if you give the office $50. This is 50 right here. So you go bam, 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 bam. All right, I'm at the graph. Then you go all the way. Actually, I drew that last point on the graph a little bit incorrectly. Let me, so that 55, 35 is right here. Let me redraw that point. So 35 is right there, roughly. So 55, 35 is right there. So let me redraw my line. It will look, I lost 25. 25, 14 is like right there. So my graph looks something like that. That's my best attempt. Now, let's answer the question. If we give them $50 right there, you go up, 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 $50. The person is going to get, you go all the way to the left-hand side. That's right about 31.50. We figured out exactly using the formula, but you can see you can eyeball it from the graph and figure out any amount of dollars. If you give them $20, you're going to go all the way over here, and you'll figure out that it should be, well, $20 should be about $7.50. So the imprecision in my graph, my drawing the graph, makes it a little bit less exact. When you say 20 minus 5 is 15. 15 times, actually, it'll be a little over $10, which is right. So it's right over there, right? If you put $20 in there, 20 minus 5 is 15. 15 times 0.7 is $10.50, which is right there. So you can look at any point in the graph and figure out how many euros you'll get. Now let's do this one where we'll do a little bit of reading a graph. The graph, I think it said use the graph below. Oh, the graph below shows a conversion chart for converting between weight in kilograms and weight in pounds. Use it to convert the following measurements. So we have kilograms here and pounds here. So they want 4 kilograms into weight into pounds. So if we look at this right here, 4 kilograms is right there. And we just follow where the graph is. So 4 kilograms into pounds, it looks like, I don't know, a little bit under 9 pounds. So a little bit less than, so almost, I'll write almost 9 pounds. You can't exactly see it. It's a little less than 9 pounds right there. 4 kilograms. Now 9 kilograms. We go over here. 9 kilograms. Go all the way up. That looks like almost exactly 20 pounds. 20 pounds. And then here they say 12 pounds into weight in kilograms. And actually, kilograms is mass, but I won't get particular. So 12 pounds. Go over here. Pounds. 12 pounds in kilograms. In kilograms looks like 5.5. Approximately 5.5. And then 17 pounds to kilograms. So 17 is right there. 17 pounds to kilograms. It looks right about 7.5. 7.5 kilograms. Anyway, hopefully that these examples made you a little bit more comfortable with graphing equations and reading graphs of equations. I'll see you in the next video.